Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 7-2 on similar polygons. This is some of the vocabulary and important information we're going to be covering today, so make sure you get this in your notes. First of all, we wanted to begin again with a polygon. So we've gone over this before, we just did it in our performance task at the end of quarter 2. But just so that everyone's on the same page, a polygon is a closed figure in a plane, and it's formed by connecting line segments endpoint to endpoint. If we're talking about similar figures have the same shape, but they're not necessarily the same size. And you always use this symbol here when we're talking about similarity. So you might notice this down here. This actually reads, ABCD is similar to GHIJ. There are two rules for similar polygons. The first is that your corresponding angles have to be congruent. Here in the red, corresponding angles have to be congruent. And the second rule is that the corresponding sides have to be proportional. So that's what they've shown you here in the figure, the diagram. Notice all of the corresponding angles are congruent to one another, and then all of the corresponding sides are proportional to each other. And those corresponding sides being proportional is what forms a similarity ratio. So that's the ratio of the lengths of the corresponding sides. And the important thing when you're doing these ratios is to be consistent. And I'll show you how that works in just a moment. We're also going to talk about what's known as the golden ratio. The actual numbers to the golden ratio are listed here. It's 1 to 1.618. But the importance of the golden ratio is that it's considered aesthetically pleasing to the human eye, things that are found in the golden ratio. And they're also very engineeringly and structurally and architecturally sound. So if you're going to build something, building with the golden ratio is always a good idea. And if you want something to look really nice, using the golden ratio is a great idea. They use it in logos and all kinds of stuff. Also, you find it in nature all over the place. So here's a couple of examples of that. You often find it with the golden rectangle. And a golden rectangle is a rectangle that you can then divide into a square and another rectangle that is similar to that original rectangle. And no matter how many times you break that rectangle up into a square and another rectangle, all of those rectangles are proportional to each other and to the original. The golden rectangle kind of looks like that. You can notice around the outsides of the big thing is a rectangle, and then it breaks into a square and another rectangle. And this rectangle here, A and B, is a proportional rectangle to the original rectangle here of the whole thing. And so here are some examples. So this is Notre Dame Cathedral in Paris, and you'll notice all of the golden rectangles. It starts, way down in here like this, and then that rectangle gets bigger, to this one, and then it goes to this one, and then to this one, and so on and so forth. And what you end up making is kind of this swirling pattern here, and you'll see that in a lot of different things as well, like the human ear, and seashells, or even a hurricane, and even the spiraling of the Milky Way galaxy. This diagram here just shows the golden ratio as a straight line, and here's an example of how that gets used. And here's another example on our arm. Here's an example from fashion. And here's an example of two very well-known logos. Anyway, the point is that the golden ratio and the golden rectangle are used all over the place. So here's one of the questions from your practice. They want you to determine whether the parallelograms below are similar. And so we can use the sides here, BA and KJ. BA has a length of 2, KJ has a length of 4, so that would reduce to 1/2. And then if we did the BC on the top and the KL on the top, that'd be 1 to 2. If we did the right-hand side, CD and LM, that would be 2 to 4, which again reduces to 1/2. And then if we did the bottoms here, AD and JM, that's 1 to 2. So if you notice, all of these are 1 to 2, which means that they are definitely proportional. So now we just have to check the angles, because remember the angles have to be congruent. So angle K here and angle B would have to be congruent. But notice angle K is 100 and angle B is 120. So even though the sides are proportional, the angles are not congruent, which means that these parallelograms are not similar. Here's another one. They want us to solve for the value for x, and you can do this a number of ways. One of them is to set it up using a proportion. If we know that the figures are similar, we can do that. So we can set up the proportion using the red sides and the yellow sides. So the red sides here in the small triangle is x, in the large triangle it's 50, and on the yellow sides here, on the small triangle it's 12, and on the large triangle it's 40. And again, remember, being consistent is important. So if you use the small triangle first on the top, you need to use the small triangle first on the bottom, or vice versa. Then you can just use the cross product property to solve. And when you do, what you get is that x equals 15. And then here's our last one. We want to complete this congruent statement below. So you can either use the image or you can use the congruency statement, whichever one you're more comfortable with. So if we're going to use the image, JD here is along the left-hand side, the large polygon, and JH is along the left-hand side, the small polygon. And then DR is along the top of the large polygon. So we would need something along the top of the small polygon, which would be here, and that would be HY. You can do the same thing if you use the congruent statement, the similarity statement over here on the right. The JD would be here, the first two spots, and the JH, again, the first two spots here. The DR would be the two in the middle, so we would need the two in the middle over here. And either way, you get HY. Good luck, everybody. I hope you guys all do great.